We're going to explain the related rate of change.
The rate of change is the speed at which a variable changes over a specific period of time. It is often used when speaking about momentum and usually can be expressed as a ratio between a change in one variable relative to a corresponding change in another. Graphically, the rate of change is represented by the slope of a line, and it's often illustrated by the Greek letter of delta. Okay, we have a falling ladder that is falling at a rate of 4 meters per second. The ladder is 20 meters long, and the distance between the wall and the base of the ladder is 12 meters. Okay, so now, because of the Pythagorean theorem, we know that x squared plus h squared equals c squared, where x squared we're gonna call the distance between the wall and the ladder. So x is equal to 12. So 12 to the square plus h to the square, that is what we want to know, it's equal to 20 squared. So h squared is going to be 400 minus 144. Now we know that h is equal to 256 squared, so h is going to be equal to 16 meters. Now, we want to know how fast is the ladder moving straight down at x given moment. Now that we have the height of the ladder, so now we can finish calculating the velocity at which the ladder is falling with the same equation that we had of x squared plus h squared, it's equal to 400. Here we need to find the change of x plus h squared with respect of time, also this side. And now we have to find the derivative of x squared, which is 2x times, we're going to multiply it, the change in x over the change in time, that is the velocity at which the ladder is moving down, or horizontally and down. So times 4 plus the derivative of the height, that is 2h. But now we want to know the rate of change at which the height changes with time. So it's going to be 2h times the derivative of h related to the derivative of time, well, related to time. And as you know, the derivative of a number, it's always 0. So now we can substitute in the values that we know. 2 times the x that we already know, that it's 12, times our 4 meters, that is the change in distance over time, plus 2 times h that we calculated here, 16. And the thing we want to know is the velocity at which it is going to fall, well, the ladder is going to fall, that it's the change, the derivative of h related to the time, equals 0. Now we make the operation, it's going to be 96 plus 32, that multiplies the height over the time. Now we know that 32 is going to be equal to minus 96, and finally our derivative is going to be equal to minus 96 over 32, that it's equal to negative 3. And this makes sense because the ladder is going down. So our final solution is that our change in height over the change in time, it's equal to negative 3 meters per second.
So now a little close-up of what we have seen in this problem. So we applied basic knowledge of derivatives. Here we know that the rate of change in this problem according to x is the velocity. What we try to find out is the velocity when the star was falling down. So then it was according to age, the rate of change according to age.
And that was all, folks. Thank you.